All right, guys, this is my second attempt at trying to get you a video to understand what's going on, because I definitely had gotten some feedback that some of you are still a little bit confused. Others are doing fine, and you've checked your solutions. So today's going to be kind of a recap of everything that we should have learned and hopefully not fall behind. So some of you are still kind of confused of what exactly a derivative is. Why are we doing this? A derivative is the instantaneous rate of change at any x value. So if you look at this curve that I have here, that's called f of x, all right, and I have these different x values that I've labeled a, b, and c, all right, and if I move along that and I want to know what's the rate of change when x is a, I'm asking you to tell me the slope. The rate of change is how something is changing, but I just want to know what's happening at x. So remember when we did the definition of a derivative and we brought those 2 points together so close as h approached 0, that space between the 2 points was 0, we created this tangent line. So this, in this case, the rate of change at when x is a is going to be some sort of positive value. As you see, it's a positive slope because from left to right it's going up. If I, on the same curve, get to b and I go, well, what's the rate of change at b? Well, the slope of the tangent line, geometrically, that's what shows the derivative, the instantaneous rate of change, is negative. On the same curve, if I ask you what's the rate of change that's happening at c, when x is c, we have yet another positive rate of change. So as you see, as we go along this curve, the rates of change change at every different x value. So when we're creating these rules, these derivatives, and we get an expression, just as if I said, oh, the derivative is equal to 2x minus 1, well, that 2x minus 1, let's just say, it was not the derivative to this one, but if I said the derivative was 2x minus 1, well, I would find the value, the instantaneous rate of change at a by plugging in a for x. This happens to be the rule for you to calculate all the rates of change at whatever x value I want. So before we go on to look at the power rule, I'm just going over notation. So again, just to make sure that everyone's on the same page. If I give you a notation for f for a function, I can give it to you as f of x, or I can give it to you as y equals, are my two common ways. Well, if I give you f of x, well then the notation for the derivative is f prime of x. If I give you, so from f of x, the notation for the derivative of f of x is called f prime of x. The derivative for y, when I call the function y, it becomes dy dx. And what that really is the derivative of y with respect to x. Meaning this variable down here, x, that's the independent variable. So that's telling me that y is in terms of x. So if I had a function y equals 2x plus 3, and I want to take the derivative of it, my notation would become dy dx because the independent variable is x. If I had another function that was y equals 2t plus 3, well then my notation would be dy dt because the independent variable is t. This is all just notation, but important for you guys to recognize what it is that you're doing. Here, another way to say y equals for a derivative is this little prime mark. All right, so y prime is another way to represent a derivative. This all means the same thing, but these are the three notations that you will see. And again, I don't think I have to say this, but if it was h of x, then you would see h prime of x for the derivative. Right, so now that you have your notation clear, we're going to just review the power rule and what it meant for those of you that were a little confused. So the other day I put up on my video that some of you were able to access that if I give you a function to be f of x is equal to a coefficient, the base with the exponent, the way that I can find the derivative, avoiding the definition of a derivative, is using the power rule. But the power rule only works when the function is a polynomial. And what do I mean by a polynomial? A polynomial is just many terms. I don't want to see radicals and I don't want to see fractions. We would have to rewrite that. So once I do that, what you're doing is you're taking that exponent and bringing it in front and multiplying it with whatever the coefficient is there. Now I'm going to tell you something really important. This coefficient cannot be another variable. It could only be a number. So that exponent gets multiplied to a number, a value, no other variable. And then you get a times n. But then what do you have to do with that exponent? You drop it down by 1. Now one of my students asked, they understood the mechanics, but they didn't really understand why. This is just different differentiation rules that you're going to learn. There's 4 of them. There's something called the power rule, the product rule, the quotient rule, and the chain rule. And you're going to learn that by the end of this unit. So what I put up here was a little bit of a practice. So some other questions to address. If I look at this, I ask myself, first of all, is this in a polynomial? Is this in the right form for me to take the derivative? And it is. I don't see any radicals. I don't see any fractions with variables in the denominator that I need to change. So I can go ahead and take the derivative. So y now becomes the derivative of y with respect to t. So I'm going to write dt instead of dx. Then I continue by taking the derivative. I take that 2 and multiply it. The coefficient happens to be 1. So 2 times 1 becomes 2, t, and then I drop that exponent by 1. So it's to the first power now. Now I continue, plus the coefficient here, the exponent here is 1, and I multiply it. And I get 2 times 1, which is 2, but I drop this down by 1, so that becomes t to the 0 power. And that does become 1, but I'll come back to that. And there was a lot of questions on why did I just drop the 3? Well, because this is a constant. What I actually do have here is a variable, but that we don't see the variable because the variable is to the 0 power. Now, if I go ahead with the power rule and take that 0 and multiply to the coefficient, 0 times anything just turns into 0. So that's a very, very important rule. The derivative of a constant becomes 0. So now to clean this up, you would say dy dt is equal to 2t plus 2 times 1 is just 2. So that's my answer. So what you're going to notice is that whenever you have a term that has the variable raised to the first power, your derivative is just a coefficient, because what happens is when it drops down to 0, that variable goes away. Okay, looking at number 2, I go, uh-oh, there's a problem. I have a variable in the denominator. This is not in the correct form for me to take the derivative. So I need to rewrite the function, and that's tonight's homework, is going to be that fact that you're going to have to rewrite some of the presented functions. So I need this x to not be in the denominator. That 3 can stay there. I don't want to move the 3. I just want to move that variable, and that variable has the exponent 2 attached to it. That 2 is not attached to 3, because if it was, you would have needed a parentheses around that. So I'm going to bring that variable up, and if I move my base, you know I need to do that by using negative exponents. So therefore this becomes y equals 2/3, and the x becomes -2 in the numerator or off to the side, whichever way that you're comfortable with. Now, if you notice, my notation for the function did not change because I did not take the derivative yet. I just rewrote it. That's our first step. Now that I look at this and I say, okay, I have no variables in the denominator, I have no radicals present, I can go ahead and take the derivative. So when I do this, this now becomes dy dx in this case, because the independent variable is x. That exponent comes into the front, and it becomes -2 times 2/3 x, and then this drops by 1. And when that drops by 1, that becomes x to the -3. So now dy dx is equal to -4/3 x to the -3. Now, did I start with negative exponents? I didn't, so you shouldn't submit your answer. If you didn't start with negative exponents, you shouldn't submit your answer with negative exponents. So my very last step is to take the -4/3 and bring this back down, and x cubed is found in the denominator. Okay, moving on to other problems. There's 3 more that we need to get through before I give you your homework. If you look at this, again, I see there's a little bit of a problem. I have a variable in the denominator. So if you can't read it perfectly, it's f of x is equal to pi, and in parentheses is 3x all raised to the second power. And here, what I want to do is I want to simplify this base. I don't want to bring this whole thing up because I only can work with the variable being moved up. So again, I'm going to rewrite this, and we know that 3x squared just means 3x times 3x. And when that happens, I get f of x is equal to pi over 9x squared. All right, now I'm ready to rewrite the function and just bring that x squared up. And again, if you know, I haven't changed this to f prime of x because I haven't taken the derivative. This is just pi over 9x to the negative 2. Now that this is in proper notation, I have no variable in the denominator, I can go ahead and do the power rule. So when I do this, the actual taking the exponent and multiplying it to the coefficient, I have now started to take the derivative, so my notation goes into place. This becomes negative 2 pi over 9x, and I drop this by 1 to the negative 3. And then my very last step is to put it back with no negative exponents, so I get 9 with the x cubed on the bottom. This goes back down. Okay, so that's the problem to number 3. Number 4 was very similar to number 5 on the homework that you had the night before. A lot of you were trying to take the derivative in this form, but again, we need a polynomial. I don't want to see the product of anything. I don't want to see division on any of these functions. I want to just see a polynomial, many terms. So here I need to distribute this 3x first, and I get y is equal to 3x cubed minus 6x over x. Did I do that right? I did. Okay. Again, this simplifies, so now I just get y equals 3x cubed minus 6. That takes care of the issue that I had a variable in the denominator that I thought maybe I'd have to bring up, but I didn't. It just simplified on its own, and now I can take the derivative. This just becomes dy dx is equal to 9x, and then we drop this by 1, so 2. And then what happens to this constant? As I said from the beginning, it's a very important rule. The derivative of a constant just becomes 0, so this goes away. All right, last one. Oh, I lied. There's 2 more that I picked. Okay, so here, again, I know that I can't take it in this form, so I'm looking at this and I'm going, oh, okay, I have to go ahead and simplify this. I'm not allowed to distribute the 3 in because if you see that exponent there, I can't distribute when a binomial is raised to a power other than 1. So this tells me the only way to simplify this is to actually expand this out. And we know that when we have a binomial squared, we just have to double distribute, and we get f of x is equal to 3, and that becomes inside 25 minus 5x minus another 5x plus x squared. Keep on cleaning this up. This becomes 3, 20 times 25 minus 10x plus x squared. And then last but not least, I continue cleaning this up and I distribute that 3, and it becomes 75 minus 30x plus 3x squared. All right, so now I haven't taken the derivative. That's another big mistake, is that we do all this work and we think that, well, we did a lot of work, we're done. But don't forget, we didn't take the derivative yet. So now the notation goes into place, and this is in the proper form. It's a polynomial, and the first term I happen to have is a constant. Well, we know the derivative of a constant is 0. And now we go on to take the derivative of the next term, because that just goes away. This 1 gets multiplied, I get negative 30. This drops down by 1, so x to the 0 power just goes away because it's 1. So then I continue on to the next term. That becomes 6x to the first power. And that's my final answer on that problem. Okay, last but not least, you guys have been troopers. We got y is equal to, I see the radical. I have to rewrite it. All radical functions can be rewritten as a fractional